Ram. Hearty welcome to SSSLSG Gurukulam online classes, force and pressure. How are you all? Fine? Okay. You had nice dishes? Very nice. Come on. Be attentive. Don't get up from the place for only half an hour, okay? Just half an hour and just note down some of the important points. Before we come to today's topic, we will see the lessons we have covered in the previous classes. So we have studied about force. In that force, we have talked about contact force and non-contact force. Can you give an example of contact force? Yes, muscular force, that is contact process. If you push a book or a table, etc., that is muscular, and you are touching the table, touching the book, that's called contact. Non-contact, magnetic force, electrostatic force, they're all called non-contact. Even gravitation force also, we can't see it, correct? Example of different kinds of forces, muscular, just now I told about friction. When you hit a ball with the bat, the ball will move in the ground for some distance and stop. Why does it stop? It is friction, correct? So you are standing here, you are sitting there. There is also a friction between our body and the floor, correct? So in the smooth surfaces, friction will be less. In the rough surfaces, friction will be more. So it is both advantages and disadvantages also there. Magnetic force. Other day we told about two magnets coming near. When the two poles are like poles, repel each other. Unlike poles, attract each other. That's called law of magnetic poles. So we also seen that magnet attracts magnetic substances like iron, cobalt, nickel, etc. And electrostatic forces. Electrostatic force means when two charged bodies are come together, like charges repel, unlike charges attract. So charged bodies. You heard about lightning. How lightning is caused? Because of the two oppositely charged clouds come near, there will be a electricity produced. That is what is called lightning, with a lot of sound. And gravitation force, any body thrown upwards is bound to come down. Is it not? And you have seen how the fruits fall from the tree. Coconuts fall when it is dried. Correct? All this falling is because of gravitational force. Okay? Also we have seen about pressure. Pressure is nothing but force acting on a unit area. The formula for pressure is equal to force by area. More the force, more is the pressure. More the area, less is the pressure. Lesser is the area, more is the pressure. Okay, this is inversely proportional, area and pressure. Force and pressure are directly proportional. So, pressure is the force acting on a unit area. And we have seen about pressure exerted by liquids and gases. We are told that in dams, the bottom of the dams will be broader in area. Is it not? Why? It has to withstand the pressure of the water stored. Have you seen dams? D-A-M, dam. You have seen it? Okay. Where you have seen? Yes, KRS Dam. It is in Mandya district. Correct? And then you have seen, heard about Linganamakke Dam in Sharavati, Jog Falls, near Jog Falls. Correct? So many dams are there in Karnataka and abroad in all the states. So there all the dams will be, bottom of the dams will be broader in area. And in liquids also, when a pressure is applied to one point, it is distributed equally in all other points. And as you know, the depth increases, the pressure also increases. That's all what you have seen. Similarly, in the case of gases. Gases have no shape of their own. It occupies the shape of the container. For example, if you balloon, if you blow it, inflating it's called. So the volume increases when you go on blowing. You have seen it now? Yeah. And then you have to tie it with a thread. Correct? Then it looks a very good shape it takes place. Suppose you press it, the size becomes smaller. Correct? So when a pressure is applied to gas, the molecules will be compressed. Okay? This is all what you have studied in the previous class. Now let us see the home assignment. First question. A rocket has been fired upwards to launch a satellite. You heard about rocket? Yeah. And it is having a nozzle at the top. And the shape of the rocket is called streamlining. Is it not? It ejects out gases. So what does the rocket do? Some rockets carry persons also. But some of them carry satellites. So they carry satellites and leave it in the orbits. So by doing so, what makes the rockets go up? Even though gravity is there in the earth, it will go against the gravity. That is what is called as escape velocity. You should move with the escape velocity about 11 km per second to overcome the gravity. So the question is, name the two forces acting on the rocket immediately after leaving the launching pad. Heard about launching pad? Yes. Where it is? In Sriharikota, in Andhra Pradesh, on the bank of the sea, the Bay of Bengal. So you have a launching pad. And where do the rockets be prepared in India? Rockets are manufactured in Tumba, in Kerala. And what about satellites? They are manufactured in ISRO, Bangalore. So you are asked to answer why, what are the two forces? So one force is burning of rocket fuels, eject gases and flame that comes out below. Okay? Burning of fuel. When you say fuel, there are liquid fuels, gaseous fuels, solid fuels. Correct? So these fuels, when they burn, you might have heard how the rocket is fired into the space. Countdown, what do you call? Come on, how do they do? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. At the stroke of 1, they press the button. Rocket will start moving. Have you seen the videos? Yeah. So what that rocket do? It eject gases and flame. And when the gases and flame come out, with equal and opposite force, it goes up. That is in Newton's third law. Anybody heard about Newton's law? Not yet. Okay, next year you are going to study. There is one Newton's law. Who was Newton? Sir Isaac Newton was a famous scientist, physicist of England, who has discovered so many things, out of which the three important laws of motion. And the third law says, For every action, there is an equal and opposite reaction. So, with whichever force the gases and the flame come out, with the equal and opposite force, rocket will go up. That is what I said about escape velocity. Its value is about 11 km per second. Of course, when rocket leaves the pad, it will be about 2 kilometers. As you go higher and higher, the velocity go on increasing. So, that is called upward thrust. So, these are the two forces we can find in a rocket. Okay. Now, second question. When you inflate a balloon, you seen a balloon? Yeah. For all the functions and festivals, they use balloons. Why do you have to close its mouth? Can you think of the answer? Second question, what happens when you open the mouth of the inflated balloon? If you just open, what happens? That is the question. Of course, you can have your own answer. One of the answer is like this. If you do not close the mouth of the inflated balloon, it will fly off in the opposite direction with the pressure. So, when you fully inflate it, it's called inflating means what? Filling the balloon with air, that is called inflating. And throwing the gases or air outside is called deflating. So, here you are blowing it, correct? As you go on blowing the balloon, the size will go on increasing. Of course, there is a limit. Don't blow once for all. Let it break off. So, until one limit, you can go on blowing. Then you have to tie it with a thread. Correct? So, here, if it is not tied, what happens? Balloon will fly off in the opposite direction. Air will go one direction. Balloon will fly in the opposite direction as per Newton's third law. Okay, that is the answer for the first question. Second question, when you open the mouth of the inflated balloon, air will come out with pressure, with a noise, due to the pressure of the air. That was you heard. How shrill noise come. Why it comes? Because of pressure of air that is gushing out of the balloon. So that is the answer for that question. It is general question, of course. One more question. The bottom of the dams will be broader in area than the top. Why? If you have seen the dams, you can understand easily this question. So when a dam is built, lot of area will be filled with water. Correct? Reservoir, what you call, or you can say backwaters. So, of course, that will be channelized with the channels to the different agriculture areas. So, there will be more pressure as we go deeper in water. To withstand the high pressure, the bottom of the dams will be broader in area than the top. So, when water is stored in such a huge area, it will give more pressure to the dams. So, to bear that, the bottom will be broader in area. Okay. Now, we will see today's topic. It is about atmospheric pressure. What is atmosphere? You heard about hydrosphere. Hydrosphere means what? It is the layer of the earth with water. It consists of sea water, river water, lakes, isn't it? Ponds, streams and so on. That is called hydrosphere. There is one more called lithosphere. It consists of hillocks, rocks and all. And this is about atmosphere. What is atmosphere? The envelope of air. Envelope of air all around us is known as atmosphere. What does it contain? It contains gases like, come on, nitrogen, oxygen, water vapor, and so on. That is atmosphere. And what is atmosphere? Pressure. The pressure exerted by this air is known as atmospheric pressure. How to measure it? It can be measured by a device called barometer. Barometer. Heard the word? How do you measure the temperature of a body? Thermometer. Correct. Similarly, you have got a barometer. This is aneroid barometer. Actually, first barometer was with mercury, but now it is dry here because this is used in aeroplanes and rockets where there is no mercury columns. So it shows, see from here, stormy, rain, change, fair, very dry, like that. The weather conditions, depending on the weather conditions, the pressure changes. Correct? So barometer is a device to measure the atmospheric pressure. Where do you use it? Use in the ships also. Use in the flights also, rockets also, because the pressure is to be calculated then and there. And who discovered this? Barometer was discovered by an Italian scientist, Torricelli. Torricelli, the value of the atmospheric pressure at sea level is 76 centimeter of mercury. Okay. So, how do you get 76 centimeter of mercury? So, what Torricelli did was, he took a 1 meter long tube, glass tube, filled it with mercury and kept it in mercury bowl, and he actually covered it with a thumb. When he removed the thumb, the level of mercury came down. Why does it come down? Because there is a pressure of air. 24 centimeters reduced from 1 meter, so it becomes 76 centimeter of mercury. That is how the word 76 centimeter of mercury or 760 millimeter of mercury we call it. So formula for pressure is force per unit area. We can imagine a unit area and a very long cylinder standing on its filled with air. Then the force of gravity on the air in this cylinder is atmospheric pressure. So what is atmospheric pressure? Atmospheric pressure means, see, this is a tube of 1 meter length, and the pressure on this 1 unit area means 1 square centimeter you can take. So atmospheric pressure is the force of gravity on air in a column of unit area. So the force of gravity here on unit area, that is called as atmospheric pressure. Okay. Now let us see 1 or 2 activity connected to it. So here you can see a rubber sucker pressed on a surface. You have seen that? Sucker means what? Here you can suck the air. So when it is pressed on this table, you cannot remove it as easily. Is it not? A good quality rubber sucker is taken. This is called rubber sucker. There will be a nozzle here, and it looks like a small rubber cup. So it is a rubber cup, something like that. Actually, this is the shape. It is pressed hard on a smooth plane surface. By this, most of the air between the cup and the surface escapes out. So when you press it on the table, all the air that is inside will go off and it will stick on to the table. The sucker sticks to the surface because the pressure of the atmosphere acts on it. So the pressure of atmosphere acts on it. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. So here when you want to pull it up, pressure must be more. Even though it looks very small here, you have to apply the all force. Okay. So this is a boy carrying a glass tube. So here, how much of pressure we are getting, each one of us. So mystery is we don't understand. So much of pressure is all around us. That is God's mercy. We don't feel it. For example, if our head area is about 15 to 15, length is 15, breadth is 15, let us suppose. Then the force of gravity on an object of mass 15 into 15, 225, will be 2250 newtons. N means what? Newtons. What is Newton? Newton is a name given to a unit of force. Of course, you are going to study later. We call it as 1N. When a 1 kilogram of formula is F is equal to ma. 1 kilogram of mass produces an acceleration of 1 meter per second square. We are going to study that next year. Then that force is called 1 Newton. Okay. So here it is 2250 newtons. Of course, it may vary from person to person. Approximately it is so. So 15 length, 15 breadth if it is there. So much of force is, so much of pressure will fall on that. The force of gravity is that pressure inside our body is also equal to atmosphere pressure and balances the pressure from outside. From outside it is 2050 newtons. From inside also pressure is there. So this inside pressure balances the outer pressure. That's why we are happy and safe. Otherwise, we would have felt a lot of weight, like this fellow we hang here. We don't feel it because the pressure inside our body, the external pressure, both will be equivalent. They balance each other. And there is an interesting experiment done by a scientist called Otto Gerich. So that is called his famous horses of hemispheres. Horses tied to the pulling the hemisphere. So what he did is he took two hemispheres. What is hemisphere? Half of the sphere. Ball, tennis ball, correct? That is called sphere. Suppose cut the tennis ball in it two. Don't try. Only if it is spoiled you cut. Otherwise don't try because one ball costs so much of costly it is. Should not waste it. Correct? Suppose the ball is torn out or damaged. Then you can cut into two parts. What do you call it then? You call it as hemispheres. So here a scientist by name is German scientist Otto von Gerich. Gerich is name. Otto von Gerich, a German scientist of 17th century. What he did? Invented a pump to extract air out of a vessel. So this was the balls. He invented a pump to extract all the air from the vessel. With the help of this pump, what do you call it also as exhaust pump or vacuum pump, better word, vacuum pump. He demonstrated dramatically the force of the air pressure. He joined two hollow metallic hemispheres of 51 centimeter diameter, means half meter diameter, means 25 centimeter radius. So he took two hemispheres of 51 centimeter diameter each and pumped air out of them. But it was a very tough job. Then what did he do? So then human beings could not pull it up. Then he employed 8 horses on each hemisphere. So 8 horses here, 8 horses here. You heard the word horsepower, HP. Correct? That is a unit used to measure power. So here 8 horses were brought on each side to pull the two hemispheres of 51 centimeter diameter, and great is the force of air pressure that the hemisphere could not be pulled apart. So when the air inside them was removed, it's a very challenge. They could not open these hemispheres. Why it happened? Because there is inside, there is no air inside. Vacuum it has become. So because of that vacuum, these two hemispheres could not be pulled out. So this was an interesting experiment conducted by Otto von Guericke. Okay, so this is a very interesting experiment to show that atmosphere pressure is one of the interesting things, and it is very powerful also. Okay, and now let us see the home assignment. First question: define atmosphere pressure. What is its value? What does the Guericke's experiment on horses pulling the hemispheres indicate? What is atmosphere? So prepare answers for that. One more, name the important gases present in it. Important gases present in the atmosphere, in it. You must tell in it. In it means in atmosphere. Now before you close, let us see what Sadguru Sri Madhusudan Sai says. So this is a beautiful photo of Sadguru Madhusudan Sai. He says, first you be whatever you want to others to follow, that we have to do ourselves. Then you do. Actions speak louder than words. Then you see. Then only you tell. So before telling, you have to behave like that. You have to do in action. You have to see it. Then only you have to tell. This is the formula for transformation. So if you want to transform others, first you have to act according to it. Suppose you say, all of you be always smiling. You know how to smile? Yeah. So if you say that all of you must have a smiling face, first you have to demonstrate how to smile. Correct? Show by action. Then only you can say to others. Okay, this is a beautiful message of Sadguru Sri Madhusudan Sai. See how smiling he is. Correct? So come prepared with the answers. Thank you.